Okay, now we get to a question on pipes. It says a pipe open at both ends is 22 centimeters long, and the velocity of the sound, let's assume the velocity of the sound in the air is 343 meters per second, which means that we are assuming the temperature in the room is about room temperature, right? So what is the fundamental frequency and the third overtone? So I'm asking the similar question that I asked for the strings, fundamental frequency and third overtone, so we can compare them and see how different this will become, right? Fn, which equation do we use here? Open at both ends is the same equation as closed at both ends, which is also the same equation as the strings, right? So it's just going to be NV over 2L. So we're going to put N is equal to 1, 343 over 2, and then the length of the string is equal to 0.22. If the temperature in the room had been given to us, then we would have used the equation for the velocity of the sound in the air. We would have calculated what the velocity of the sound was. Then we would have put it into here. Then we would calculate what the frequency is, right? So the answer for this one is going to be 779.5 hertz. Example of an instrument like this, like I mentioned before, is like the flute that is open at both ends. So the length of that will be from where you are blowing into it and then where you are pressing on the opposite end, right? Okay, so now let's calculate the third overtone. Well, since the ends work the same as for the strings, we're going to use N is equal to 4 also for this one. So F4, 4 times 343 over 2 times 0.22. Well, it's essentially like taking this frequency and then multiplying it by 4. 3118.2 hertz, and that's very high frequency. Our ears will mainly hear the fundamental frequency, of course, but the pipe will also make these other frequencies at a very low intensity compared to the fundamental frequency, right? So next we will do an example on the type that is closed at one end and open at the other end, which is similar to the clarinets and the trumpets, okay? Thank you very much.